Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem, which is n queen problem, and it is a very famous backtracking problem. So here we have given an integer n, and what we have to do is we have to form a chessboard of that particular size, that is n cross n, and check that what are the different possible position of the queen on which we can place it on the chessboard, so that there is no like there is no attack of queen on each other. So let's see this. So let's suppose we have a 3 cross 3 chessboard. So what we can do, let's suppose we are placing first queen here. Then what happens is that in the second row we cannot place it here because it will attack it. We cannot place here also because it will attack it. And then if we place here, then yes, it is a safe zone. Now when we come to the third row, then you can see that here there is a chance of attack, and if we put here, there is also a chance of attack, and if we put here, there is also a chance of attack. So in this case we can say that there is no possibility of placing the queen such that there is no attack possible. So let's increase our n. So let's suppose we can now talk about for n equals to 4, that is 4 cross 4 matrix. What happens is that if we place our queen here, so let's suppose we are placing the queen here, then what happens is that in the second row we cannot place it here, so we can place it here. Now in the third row what happens is that we cannot place it here, we cannot place it here, we cannot place it here, and we cannot place it here because the attack is from here, from here, from here, and here it's from here. So we cannot, the the placing of this would not be a better solution, so let's place it here. So here you can see that for the third row, now we can not place the queen here. We can place the queen here. So we placed it because there is no because there is no, let's suppose, because there is no attack possible in this case. So when we are talking about attack, then we can see that we are looking in upward direction and in downward direction. So whenever we are talking about attacks, then what we can see is we are looking in this direction in just a minute. Okay, so whenever we are talking about attack, then we are looking in both the direction, upwards and downwards, and then here leftward to rightwards, and in the diagonal itself. So diagonal can be like this, like this, like this, or like this. So we are checking in every direction. So here it is a possible case, right? Now when we come to the fourth row, you can see that we cannot place the queen here, also not here, also not here, and also so here it has attack, here it has attack, here it has attack, here it has attack. So this is not a possible case. So that means we have to backtrack, and each time we backtrack we found that this is not the correct placing. So if we place it here and again we check, now the queen cannot be placed at this position, so let's place it at this position. Now what happens is that for the third row it can be placed at this position because there is no attack in any direction, not diagonally, not vertical or row wise or horizontal. And again we can on the fourth row we can place the queen here. So this is one of the possible approach which we can follow. Also we can see that, let's suppose so this is one of the possible approach. So by this way we are actually approaching this problem. So let's dive into its coding part. So firstly, here we have given a vector int which is the return type, which is going to contain here you can see that for this particular example we are considering the column. So here the column is 3, then 2, then so here it is, you can see that here it is column number 3. So that is column 3, then column 1, then column 4, then column 2. So this is one of the possible solution. So that's why we are making it in a form of vector and then placing it inside another vector. That's why our answer is a nested vector int. So what we are doing is we are firstly making an vector int which is going to store the answer, and then a different vector which is going to have the size of the matrix and initialize each element with 0. Now what happens is that we are going to call a function which is of type void, and in this function we are going to do some computation to check whether we can place the queen at that particular index or not, and if we can, then we can update our answer vector int as it is, and at the end of it we are just going to return the answer. Now let's look how this function fucn works. So it is going to take parameters answer, t is basically the matrix, n is the size of the matrix, and r is the initial row. Now what we check that the base condition is that if our row become equals to n, then what we do, we just call another function add and return. So let's look how this add works. So add is something, let's suppose we have answer vector and a vector t. So let's suppose if we found that t contains a possible set of solution. So let's suppose this is a t where a q is placed at row 3, then 1, then 4, then 2. So this is a possible t, right? So what happens is that in the vector answer vector we have to push the values of the indexes of our column. So that is 3. So if we consider one base indexing, then it would be 3, then 1, then 4, then 2. So that is what we are doing here. So we are making a empty vector temp, and inside it we are going to assess the matrix T, and in this we check that if that particular index is equals to I. So here Q is represented by 1, and like the empty where it represented by 0, which we has initialized 0 all the like everywhere. So whenever there is a 1, that means we had put Q there. So we check that if at matrix T for column and row ji, or for row I and column j, if we got 1, that means there is a queen. So we push back that particular column. So since we are using a zero base indexing, so what we do, we just add j plus 1 so that it become one base indexing. Now at the end of it we are just going to um, push back that particular temp in our answer vector. So so this is all about the base condition. Now what we do, we again come in this for loop. So each time we are placing, so let's suppose firstly we are placing q here. So here you can see firstly we are placing q here, then checking. So if it is not the possible case, if it is possible case, then we are placing here, then we are placing here. Again we cannot found any solution, then what we do, we just make our q here. Firstly it is become 0. Firstly we make it 1, right? But when we are not considering it, we are again making it 0, and then we are moving forward and making someone else 1. So this is how we are doing it. So here what we are doing, we are firstly checking if this is safe or not. So what safe means, so safe means this condition, that we can go in this direction, this direction, this direction, this direction, this direction. That is we can go firstly all the way to up and down, then left to right, then in all the 4 directions. So all the 4 diagonal directions. So let's see how this is safe function works. So here we have this is safe function. So what we are going to check is let's suppose it is containing the value r and c. So for each particular row and column we check that if t of ri is equals to 1 or t of I c equals to 1, then we have to simply return false, because we cannot add any of them. So let's suppose we are here, so we check for it's like we check that if we can place it here or here or here or here. So in this case we cannot place it in this particular range, right? Because then it's going to be attack, right? So that's why we are checking in this condition. So this is checking for, you can see that this is checking for the row and the column. Now also we have to check diagonally. So not only this case, but we have to check for this, this, and this. So that's why we have to check diagonally. So this is going to be have that. So isBound is a function which is basically checking the bound of each column and row. So if row become equals to 0 or column become equals to 0 or row become greater than equal to n or column become greater than equal to n, then we have to simply return false because that is out of bound condition. Else if it is in bound, then we return true. Now here firstly we are checking that if this is in bound or not. So you can see that r minus I, c minus I is basically, if we are at, if we want to place something here, then we are checking this r minus 1. So this is, so at this position r minus 1 and c minus 1 should be this, right? R minus 1, C minus 1 should be this. This is not this. Okay. Now at this position, so this one is what? R plus 1 and C minus 1. This one is going to handle this. This one is R plus 1 and C plus 1. And this one would be R minus 1 and C plus 1. So these four conditions we are going to check. And if they are if they have a queen there, that is if the value there is equals to 1, then we simply return false, and if all these cases are not, then we simply return true. So now coming back to this function, so we are firstly checking that if it is safe or not. Once it's safe, we mark it as like we can place a queen here, so we mark it as 1, and then we again call our function recursively for next row. And once we are done with it, or once we are not considering it, we are again making that as 0. So this is the overall approach to solve the problem, this. So let's try to submit this up. So this is the approach to solve the problem and queen. And if you want to access the code, then you can check the GitHub link given in the description. And last but not the least, do like, share and subscribe to this channel. And thanks for watching.